Hello and welcome to our lesson on the sine curve. So the sine curve is the name for the graph that is produced by the function y equals sine of theta, or in general when we're putting this into the calculator we're going to say the sine of x, but in trig we like to use theta as our variable in place of x, but it's just a variable. So the sine curve, again, that's just the name for the graph that is produced when we graph the function for sine of x or sine of theta. And the graph of the sine curve is basically read in the same way that we read the unit circle. So when we read the unit circle, for instance, if I say go to theta equals 30 degrees or pi over 6, right? When we're going to 30 degrees or pi over 6, we can identify the cosine as radical 3 over 2 or the sine as 1/2. Now we're going to be focusing on the sine curve today. So when we graph here, instead of looking at x's and y's, we're looking at angles and y's. And we know that those y values are our sine values. And so in our table, we're going to say what is the angle that we're looking at, and then what is the sine of that angle that we're looking at. Okay? So in this case, to make this full graph, we're going to actually look at the start of our circle until we make a complete circle. So we're going to go from 0 to 2 pi to see how this looks one time around the unit circle. Now when I'm making my table, so I'm going to start here with an angle of 0. So when we're 0 radians or 0 degrees, our sine is 0. So at 0, 0, we're going to have a point on this graph. Now I know I can go up to 30 degrees, and my sine is 1/2, and that wouldn't be too hard to graph, but I don't know that I want to mess with 1/2 or a radical 2 over 2 or a radical 3 over 2. So I'm going to go ahead and skip to another nice point here. I'm going to go to 90 degrees or pi over 2 radians. So when we're at pi over 2 radians or 90 degrees, our sine is 1. And then I'm going to, again, skip all these fractions here, and I'm going to go to 180 degrees or pi, and the sine there is going to be 0. So I'm going to go to pi radians, 180 degrees, get a sine of 0. And then I'm going to skip all these fractions again and go to 3 pi over 2. So 3 pi over 2, or 270 degrees, where my sine is a -1. And then I'm going to go full circle back to 0 or 360 degrees or 2 pi radians. And my sine, once again, is going to be 0. So full circle, we're back to 0. And then what's going to happen if I keep going around the unit circle? So this was 360 degrees, right? I can go another 90 and call this 450 here. And I can go another 90 and call that 540 there. Sorry, trying to do quick math in my head. And I could keep going around the circle. What's going to happen is that pattern of y values is going to repeat. And I can actually go backwards too, right? Get those negative angles and still have that same pattern repeating. So what does this look like on the graph? It's going to be one cycle of our sine curve. So we start at 0, 0. Now, the increments here, this is going to be kind of a thing to transition to. Okay, when you're graphing, normally it's x's and y's. The y values are pretty normal, pretty standard y values. We're not going to have to worry about that axis. But on the x-axis, we're graphing angles, and they're going to be in radians. And so the increments along the x-axis aren't going to be something that we're familiar with. It will take a little bit of getting used to. But we're going every 90 degrees on our unit circle, and every 90 degrees is pi over 2 radians. So our increments are pi over 2. So I'm going to go 1 pi over 2 here, and then I get to, so that's a 1/2 a pi, right? 1 pi over 2 is 1/2 pi. And then 1/2 and 1/2 makes 1 whole pi. And then 1 1/2 or 3/2 or 3 pi over 2. And I drew that one wrote that kind of big. So 3 pi over 2 here, and then finally 2 pi here. Okay, so those are my increments that I'm looking at to make this graph. So 0, 0, and then at pi over 2 our sine was 1, and then at pi we're back to 0, and then at 3 pi over 2 we were at -1, and then at 2 pi our sine was back to 0. And then it would just repeat, so I could keep going along the x-axis and keep making the same pattern. And so what we're looking at is a picture that is something like that. Okay, so this is what we call one cycle of the sine curve. This is what one cycle is going to look like. Again, I could keep going on the x-axis. That same pattern is going to keep repeating because as we go around the unit circle, right, it's the same values over and over and over. And if we wanted to be really good here, we would draw in our midline on the x-axis. So we would say that we have a midline, and it is at the x-axis, which is where y is equal to 0. Okay, so there it is, the graph of the sine curve. So just like the previous lesson we saw, this is a graph that represents a periodic function. So it is periodic, it is cyclic. You're going to see that uniform pattern of y values that repeats as we move in constant intervals of x. And the amplitude of this function is 1. We are 1 unit above the midline, and we are 1 unit below the midline. And then the period is the horizontal length, how long it took for one cycle to happen, and the period here is 2 pi. So this is kind of like the parent sine curve function. Now, just like other functions, we can do things to transform this, but in the parent form of our sine curve, these are the features, okay? We've got an amplitude of 1, and we have a period of 2 pi, so it takes, in the parent, a full circle for one cycle to happen, for those values to repeat. Now, in the interval that we're looking at here, again, that's the interval from 0 to 2 pi, we have two pieces of graph that are increasing. So this part of the graph is increasing, and then this part of the graph is increasing. So we would say that it's increasing from 0 to pi over 2. And it's also increasing from 3 pi over 2 to 2 pi. Remember, we use the x values to say where we're increasing or decreasing. And decreasing is going to be this portion of the graph, which is from pi over 2 to 3 pi over 2. So from pi over 2 to 3 pi over 2, we have a graph that's decreasing. This is just to get some vocab review in for us, okay? And then on the interval shown, where's the graph positive? So positive, remember, that means where's the graph above the x-axis, and that is on the unit circle. Where are the sine values positive? Where are the y values positive? Well, that's from 0 to 180 degrees, or from 0 to pi radians. So this section of the graph, I'm going to try to overlap my highlights here. This section of the graph is positive. That's where our sine values are positive. So we're going to be positive from 0 to pi. And then the rest of that's going to be negative. So many colors. And then let's say negative. This is the piece here that's going to be negative, and that's where our sine values are negative, and that's from pi to 2 pi. So from pi to 2 pi. And then we have a max and a min. So this is the max height that our graph reaches, and this is the minimum height that our graph reaches. Remember, maxes and mins are your highest and lowest y values. So it reaches a maximum value of 1, and that happens at pi over 2. And it reaches a minimum value of -1, and that happens at 3 pi over 2. Okay, those are the highest, lowest points on the unit circle, and so that should make sense that it's the highest and lowest points on our coordinate plane graph. Okay. Now, graphing by hand is a skill that is very useful, especially if you're in in-person classes. If you're doing stuff online, then obviously it's also useful to be able to graph with technology. Now, if you try to make a graph in Desmos or even your calculator, you're going to put in, let's see, you try to graph like you normally would, right? You're going to graph y equals, in Desmos, if you go into functions, and then there's all these options here. You want to go into trig and find sine. So sine of, we want to use x. I don't know if we even have a theta in here, but, oh yeah, it is. Let's see. Will it do theta? Was there a difference? Okay, it looks like it can handle theta, but it's totally fine just to use x since it's on the home screen. Anyway, here's our graph. Now, that that graph, if I said to graph this, is when I ask you to graph, or when you are asked to graph, you're going to be asked for specific intervals to make your graph. So if we wanted to produce the graph that we see on our paper here, we're going to want to mess with the settings. So let me just show you how to mess with the settings. You can alter the settings in Desmos using the little wrench, and you're going to see that in the upper right hand corner. So you want to click on the wrench. Okay, that's to mess with the settings. And when you get in there, projector mode, that's just, it's going to make the graph bolder. So if you like to see it a little bit brighter, you can hit projector mode, but that's not necessary. And actually, I think it's different now. It has like a light colored box and then a dark colored box. You can choose the darker one, but whatever. That's not really an important setting. What's important is where we're looking at the x-axis here and the y-axis here. So this is going to be the start and stop of the x-axis that you want to look at, and again the start and stop here that you want to look at. Now once you go back to your graph, you can kind of zoom, but what is it specifically that you want to see? That's what you're going to put in there. So you want to tell it where to start and stop on the axes. So you can set the axes to start and stop wherever you want. And then the really important part here, so, and notice too, so like if I was going to graph the one I just did, I wanted to start at 0 and end at 2 pi, I can actually type 2 pi in there and it will understand, okay? So the other part is the step, okay? We want the step to represent the increment that we're using to mark along the x-axis. So when I was marking along my x-axis here, I said let's go by 90 degrees, right? Every 90 degrees in the unit circle, every pi over 2 radians. So that is the step I used for my x-axis. Now the y-axis was pretty normal, so I just used a step of 1. Now I knew it was only going to go up to 1 and down to -1, but just to make sure I captured enough of my picture, I went ahead and set that to -2 and 2. Okay, so we're going to use the increments on the x-axis there as our step. And then lastly, the graph is going to default to radians. Normally it does not affect what we're doing. Normally we're working in radians anyway, so you're going to see that radians is already selected here. However, if you end up working on a problem where you're, solving in a triangle and something's in degrees, just make sure that you go back here and change it to degrees if you're doing something in degrees. Otherwise, leave it in the default of radians. Okay, so let's look at a few. Actually, let's go to Desmos and say we wanted to graph this particular graph, this parent sine curve from 0 to 2 pi, just so you can see it again. So I just put sine of x in there. I'm going to hit the little wrench in the corner. See if you go to projector mode, it makes it brighter if you like that. Now on the x-axis, I want to go from 0 to 2 pi, so I'm going to type that in there, and I want it to go every 90 degrees, so I'm going to put pi divided by 2 as my step. And on the y-axis, if you're not sure, you can go from a -5 to 5. That's pretty standard with a step of 1. And then if you just hit the wrench again, it will close, and then you can see basically the picture that we just put on the paper. Okay, there's your one cycle of your sine curve going from 0 to 2 pi, and you can see how it just continues. Every 2 pi we see another cycle, every 2 pi another cycle, and if we go the other direction, again, same cycle repeating every 2 pi. Okay, so technology is going to be great for graphing for us too. And I just erased, don't know what I erased. Alright, I forget to put my pen on, and then if my eraser's on and I swipe to go to my next page, it's just so sorry. Okay, so let's look at some transformations. We know transformation rules. We've seen them before. It's just, this is a new type of function, so we want to make sure that we're good. So if you had to guess about what that negative would do, you would probably correctly guess. Let me go in here. Go back to... Oh, I messed this up. Let me go back from 0 to 2 pi. And I'm going to go here from -4 to 4, just to zoom out a little bit. Okay, so here's back to my graph, okay? Stretch that out a little bit. Alright, so there's my 0 to 2 pi. Now if I just stick a negative out in front of the function, what's going to happen is precisely what you're thinking is going to happen. It's going to reflect that graph over the x-axis. Okay, so that negative does the same thing it does for all of our other functions. That makes our graph reflects over the x-axis. And so if we reflect over the x-axis, well, our starting point isn't going to change, right? And we're still looking at pi over 2 here, pi here, 3 pi over 2 here, and 2 pi here. It's just instead of going up to the max of 1, it goes down to the min, and then hits 0, and then it hits the max, and then back to 0. So it flips that one cycle of my sine curve, so it looks something like that. So one cycle from 0 to 2 pi with a negative in front, just instead of going up from 0, goes down from 0. Okay? Now what about this next one? What do you think is going to happen if we stick a 2 out in front? Well, hopefully you're remembering what that does to our other functions. If I put a 2 in front of my x squared, that would be a vertical stretch of the graph. That's precisely what's going to happen here. It's going to stretch it out. And in particular, what it's stretching is the amplitude. Instead of my amplitude being stuck at 1, now my graph goes all the way up to 2 and all the way down to -2. So this is a vertical stretch. And specifically what the vertical stretch does for our sine functions is it makes the amplitude 2. Okay, it makes our amplitude 2 instead of the amplitude of 1, which is what we see in our parent. And so 0, and then we have again pi over 2, pi, 3 pi over 2, and then 2 pi. So at pi over 2, instead of a max of 1, we have a max of 2. And then we hit 0 again. And then 3 pi over 2, instead of a min at -1, we have a min at -2. And then we hit 0 again. So we are stretched out to have this higher max and lower min, right? So there would be one cycle of 2 sine of theta from 0 to 2 pi. Now, the 2 moves here. I don't think we have talked about what's going to happen with the 2 multiplied by x. So when we multiply outside, we mess with the function vertically. We stretch it or compress it. Now, if we put a factor inside with x, again, I don't think we've seen this together, but that's going to mess with the function horizontally. So it could horizontally compress or stretch your graph. So let's look at what moving the 2 does. If I put 2 in here, what happens to that graph? So remember, we're looking from 0 to 2 pi. 0 to 2 pi. Now there are 2 cycles in there instead of 1. So this is a vertical, not a vertical, this is a horizontal compression. This is a horizontal compression. We like squished it horizontally. Okay. Now specifically what it does to our sine curve is it creates 2 cycles from 0 to 2 pi. 2 cycles from 0 to 2 pi. What it's affecting is what we call the frequency. It's how many cycles from 0 to 2 pi. We call that the frequency. So we've got pi over 2 here, pi here. Oops, let me make this clean. 3 pi over 2 here, and again 2 pi here. So if I've got 2 cycles to fit in here now, then the first cycle has to start and stop by the time we get to pi. And we also hit 0 in the middle. So one cycle, think about one cycle, hits 0 at the beginning, at the end, and in the middle. And then between those, we hit the maxes and the mins. So we're going to hit the max in the middle of that, and we're going to hit the min in the middle of that. And then again, we're going to have another cycle here, and we're going to hit the max in the middle of those, and we're going to hit the min in the middle of those. So now we've got 2 cycles to cram in here from 0 to 2 pi, okay? So we're seeing some effects. And now this one is, what if we're looking at -3 sine of 1/2 x? Just based on what we've done, we know that this is going to make a reflection. So that's going to reflect it. And then I know that this 3 is going to affect the amplitude. So this is going to be a vertical stretch. Too much abbreviating, sorry. A vertical stretch. And I know that this is going to be a horizontal compression. I didn't want to abbreviate horizontal, sorry. But when we reflect over the x-axis, what that really does is means from 0 we go down instead of going up. So from 0 we go down, instead of what the normal sine curve which is from 0 it goes up. If it's vertically stretched, what's happening is our amplitude is now going to be 3. That means we have a max of 3 and a min of 3. And if we have a horizontal compression, specifically what's going to happen is only half of a cycle from 0 to 2 pi. Okay, so let's see if we can do this without the calculator. And then we'll go back to the calculator to confirm. Okay, so we are looking at already labeled 0 to 2 pi. We only need a half of a cycle in here. So a half of a cycle is just going to be the first half of our cycle is just going to be basically this part of the graph. Okay, so we only have to start at 0, end at 0, and then in the middle of that hit our maximum. So we're going to start at 0, we're going to end at 0, and in the middle, which is pi, we're going to hit our maximum, and this one's going to have a maximum of 3. And, oops, this one reflects, so we're going to go down to a minimum at -3. And there it is. So we're going to connect this, and that is precisely the picture that we will be looking at. So let's confirm. If I put a -3, and then in here, 1/2, then there it is from 0 to 2 pi, the same picture that we made, starting at 0, 0, ending at 2 pi and 0, and then hitting our minimum at pi, or a minimum of -3 at pi. Okay, so it's useful to be able to do this by hand, but again, also great to be able to confirm what we're doing in Desmos. And in fact, when you work on your practice in Canvas, if I ask you to create a graph, I will tell you the specific window, but you're going to have to set the axis and give me that precise picture. So I would want you to screenshot something that looks exactly like what we'd be putting, what I would be asking you to put on paper. So I want to make sure that the amplitude is captured in there, that you have the axes clearly marked with the increments that are appropriate. All right, so the whole thing should be in there. Okay, because if you can do that, then obviously you could do this on paper as well. All right, so now let's just kind of recap what's happening here. Let's generalize some of the transformations that we saw for that sine function. So the parent function form is just y equals sine of theta. However, if we put something out here, put something in there, that's going to affect our graph. So when a is a positive number, our sine curve goes up from 0, but when a is a negative number, then our graph goes down from 0. But it is important to know that the sine starts at 0, especially when we start introducing other trig functions. Okay, so sine starts at 0, the parent goes up, and if it's negative, it's going to go down. And then the value for a itself, so not whether it's positive or negative, but the absolute value of a, whatever that number is there, it's going to tell us the amplitude. So if there's a -3, the amplitude is going to be 3. If there's a +4, the amplitude is going to be 4. Okay, so that number out in front is going to tell us whether to go up or down, and it's going to tell us how high up and how far down to go. And then b, that's the number we're going to put in here. That's going to possibly horizontally compress or stretch the graph, but specifically what it does to the sine curve is it shows the number of cycles that are going to fit in from 0 to 2 pi, which is a pretty standard interval. And that is what we call the frequency, okay, of our graph. It's how many cycles are fit in there from 0 to 2 pi. And then the period, also a feature we should be able to identify. The period, remember, is the horizontal length of one cycle. How long does it take for a cycle to happen? Oops, one cycle. So how long does it take for one cycle to happen? So if we take 2 pi and we divide it by b, which is how many cycles we're supposed to have from 0 to 2 pi, then we will find precisely that, how long it took for one cycle to happen. Okay, so let me just show you how that works here. So like in this one, if I wanted to identify the period, I would take my normal interval, my one full unit circle, right, one circle, and divide it by b. So if I divided by a half in this case, how many halves are there in 2? That would be 4. That means it would take, 4 pi, because pi didn't go anywhere. It would take 4 pi for that whole cycle to happen, which makes sense because look at the picture. We see only half of the cycle from 0 to 2 pi. So 4 pi is how long it would take for that whole cycle. Or if we look at this one, the period would be 2 pi divided by b in this case is 2. So the period's pi. That means one cycle should complete in pi radians, and it does. We see that one cycle finishing by the time we get to pi. Okay, and if we look at this one, the period would be 2 pi divided by b. Well, in this one, b is just 1, so that would be 2 pi. So it takes 2 pi radians for that one cycle to happen. Okay? And again, I can show you once more. This is going to be the same thing. Our period would be 2 pi divided by b. Well, again, b is just 1 here. So it would take 2 pi radians for that one cycle to happen. Okay? Hopefully that makes sense. And we're going to look at a few more examples, but I just wanted to reiterate what's happening here. It just looks ugly, so I need to clean all that up. Okay, so going back, let's look at these few problems here and see what we can determine. What can we tell about the graph just by looking at this function? So without having to go to Desmos or anything else, I know that this graph is going to go, this sine curve goes up from 0. And I know that the amplitude is 4. Okay, A is our amplitude, is 4. So when we go up from 0, we're going to go up to a maximum of 4. Then we'll come back down, hit 0 again. Then we'll hit a minimum at -4, and then we'll come back to 0 again. So the amplitude is going to be 4. And this 1/3 here is also telling me some information about the graph. There's going to be 1/3 of a cycle. So B is 1/3. That I wrote a third, or said a third, wrote a half. That means we're going to be looking at 1/3 of a cycle from 0 to 2 pi. And that means that the period 2 pi divided by b would be 6. If it takes me if 1/3 of a cycle happens from 2 pi, then 1/3 and another 1/3 and another 1/3, that would make the whole thing, would have to take 6 pi to happen. So the period is 6 pi, that's how long it would take for one cycle. Okay? So there's all the information we should be able to deduce just by looking at the function. So let's try that again. So this one, because there's a negative out in front, this one goes down from 0. And how far down? It's going to go to 5. So the amplitude is 5. I should have put up here. That's the max and min, right? Max, min. Up to 4, down to -4. So the amplitude's 5 here. That means we have a max of 5, a min of -5. And then B in this one is going to be 4. And so if B is 4, that means there'd be 4 cycles squeezed in there from 0 to 2 pi. So 4 cycles from 0 to 2 pi. Okay, and then the period, if I fit 4 cycles in there from 0 to 2 pi, the period is how long would it take for one of those cycles to happen? Well, that 2 pi got divided into 4 cycles. So it would take a half of a pi over 2 radians for one cycle to happen. So 6 pi for one cycle. And again, this would be for one cycle. Okay? So a lot of information we can get just by looking at the equation for the function. Now, let's look at this graph here. It says write the equation for the function that is graphed below. So right now we haven't seen other trig functions, right? So it's easy to know this is going to be a sine curve, but when you start to look at others, you got to remember that the sine curve starts at 0, okay? So this is going to be a sine curve. In order to write this, though, I know it's not the parent because it looks like more than one cycle in there from 0 to 2 pi, and I can see it's going down, and I can also see the max and min. It's 3 and negative 3. So since the amplitude here is 3, and let me call that A. I know the amplitude is 3. B is the number of cycles from 0 to 2 pi. Well, I can see one cycle that happened here, and then I can see a second cycle that happened here. And so from 0 to 2 pi, we have 2 cycles. And then I know that it goes down from 0. So if I wanted to write this equation for this graph, y is going to have to equal, it's going to be a negative amplitude of 3 times the sine of, it's got to be 2 theta, 2 cycles in there from 0 to 2 pi. And if we weren't sure if we wrote the right function, then let's just go ahead and confirm with Desmos. So let's type in, we put negative 3, and then let's change this to a 2. And is that the picture that we see on the paper? Looks right to me. So there it is. Okay? So hopefully you've got enough to get going. Hopefully this is a good introduction for you for the sine curve, that it's not too overwhelming. I know this is very new and probably very foreign. It'll take a little bit of practice, so do your best with the assignment in Canvas, and as always, if you need some extra help, just reach out. Alright guys, take care.